Hello friends, how are you? Tell me in the comment box. And I am here to discuss a new topic that is belonging to the mathematics, and this topic is very interesting and useful because I am here discussing the NCERT mathematics chapter 3 of the class 11, and this topic is very important because these topics content is useful in all the academic and competitive examination which are asked frequently, and these concepts are also useful, and you will utilize all these concepts in the whole of your academic career. So friends, stay tuned throughout all of the videos, and I I would like to request you that please share this video lecture with your friends and colleagues so that they can also enjoy this video lecture. Friends, you are watching Sciacademy channel, myself Virendra Kumar, and you will be learning in this video lecture trigonometry and trigonometric relations, important concept, important solutions, particular solutions, general solutions, and all those equations which are important. The word trigonometry is derived from the Greek words that is trigon and metron. That means measuring the sides of triangle. So the subject trigonometry is very useful, and it is utilized in many areas such as study of seismic waves, seismology, surveying of the land, describing the state of an atom, designing electrical circuits, predicting the heights of tides in the oceans, analyzing a musical tone, and many other areas of science. Friends, in the previous video I have discussed about the trigonometric ratios of acute angles as the ratio of the sides of right angle triangle. I will provide the video link in the description box. You can watch that video also. So what is the angle, how we measure it, and what units are used for measuring the angle. So friends, as you can see in this figure 3.1, first initial side, terminal side, and the vertex. So what is the initial side? So angle is measure of rotation of a given ray about its initial point. The original ray is known as the initial side, and the final position of the ray after certain rotation is called the terminal side. So as you can see that when we rotate this initial side by some angle, so it after rotation takes the final position, that is known as the terminal side, and about the point which it rotates is known as the vertex. So we denote here the vertex from by O. Now if we rotate the initial side anti-clockwise, then the angle becomes positive, and if we rotate the initial side clockwise, then angle becomes negative. The measure of an angle is the amount of rotation performed to get the terminal side from the initial side. So during measuring the angle, we use different kinds of units. Generally we use degree and radian. So we will study about the degree and radian and their relationships. So friends, degree measure. If a rotation from the initial side to terminal side is 1 by 3/60th of a revolution, then the angle is said to have a measure of 1 degree. That is written as 1 degree. So we use 1 and this sign known as the degree sign. So a degree is divided into 60 minutes, and each minute is divided into 60 seconds. So 1/60th of a degree is called a minute, and 1/60th of a minute is called the second, and that is written as 1 double dash. Therefore, we here see that 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Sum of the angles whose measures are 360, 180 degree, 270 degree, 420 degree, minus 30 degree and minus 420 degree, you can see in this diagram. So here you can see after one complete revolution of the initial side, it comes to its original position, makes an angle of 360 degree. And when we rotate the initial side to it up to its opposite direction, then it makes an angle of 180 degree. Similarly, when we rotate this initial side to this position, then it makes an angle of 270 degree. Similarly, you can see that after one complete revolution, and then 360 plus 60 makes 420. So similarly, you can see that when we rotate in the clockwise direction, then it makes the minus 30 degree. So I said that after rotation of initial side in the clockwise direction, the angle becomes negative. So when we rotate the initial side in this way, the clockwise, then angle form is the negative angle. So what is the radian measure? There is another unit of angle that is called the radian measure. Angle subtended at the center of an arc of length 1 unit in a unit circle of radius 1 unit is said to have a measure of 1 radian. That means if you are drawing a circle having radius 1 unit and you are taking an arc on the circle is of length 1 unit, then that arc will make an angle equal to 1 radian. So each radius and arc should be equal to 1 unit, then the angle subtended by the arc at the center of circle will be equal to 1 radian. So here you can see. Similarly, minus 1 radian is formed when we are measuring the angle clockwise. So minus 1 radian. Here you can see that 1.5 radian. When we are taking the arc is equal to 1.5 unit, then the radian formed at center is equal to 1.5 radian. We know that the circumference of a circle of radius 1 unit is 2 pi, because if the radius of a circle is r, then the circumference is 2 pi r. When r becomes 1 unit, then the circumference obviously will be equal to 2 pi. So when complete revolution of one initial side subtends an angle of 2 pi radian. That means if we rotate initial side one full revolution, one full rotation, then the angle subtended at its center will be equal to the 2 pi radian, because the total arc in that case will be equal to the circumference of the circle, and that is equal to 2 pi. Therefore, angle subtended at the center of a circle is equal to 2 pi. Got it? More generally, in a circle of radius r and arc of length r will subtend an angle of 1 radian. Now we are generalizing the concept that if we are taking the radius of a circle equal to r unit and the arc of length equal to r, then that arc will subtend an angle at the center of the circle will be equal to 1 radian. Therefore, we can define the relationship between radius, arc of length and angle subtended at the center of the circle by this relation: theta is equal to length of arc divided by the radius of the circle. So you must remember this relation. This is very useful relation. It may be handy for the calculation of different problems. So now relation between radian and real numbers. So how can you define a relation between a real number and radian? So for this, let us consider the unit circle with center O. So this is the circle with the center O. Let A be any point on the circle. Consider OA as initial side of an angle. Then the length of an arc of the circle will give the radian measure of the angle which the arc will subtend at the center of the circle. Now consider the line PAQ. So we are considering this line PAQ which is tangent to the circle at the point A. Let the point A represent the real number 0. So that means this is the number line PAQ and 0 number is coinciding with the point A on the circle, and this number line is tangent to the circle at the point A. Now let the point A represent the real number 0. AP represents positive real number and AQ represents the negative real numbers. If we rope the line AP in the anti-clockwise direction along the circle and AQ in the clockwise direction, then every real number will correspond to radian measure and conversely. That means if we are making the circle by the help of this number line, then total number line will lie on the circumference of the circle, and each number on the real number line will represent the radian angle subtended at the center of the circle. Thus the radian measures and real numbers can be considered as one and the same. So that way we can make related to each other. That means radian and real numbers can be related by this way. Now relationship between degree and radian. Since a circle subtends at the center an angle whose radian measures is equal to 2 pi and its degree measure is 360. 360. So you can know that when we rotate, give a full rotation of an initial side, then it makes 360-degree angle at the center or about the vertex, and that full revolution is equal to 2 pi radian. That means 2 pi is equal to 360 degree. So 2 pi radian is equal to 360 degree. That means pi radian is equal to 180 degree. So this is a very important relationship. You must remember this. Pi radian is equal to 180 degree. It is very useful and come handy when you solve the different problems. Now as we know that pi is equal to 222 by 7, generally not exact value, but we denote pi is equal to 22 by 7. In that way we can find 1 radian is equal to 180 degree by pi, that is approximately equal to 57 degree 16 minute, and 1 degree is equal to pi by 180 radian, and that is approximately equal to 0.01746 radian. So this table represents some important relationship between degree and radian, that is 30 degree is equal to pi by 6 radian, 45 degree is equal to pi by 4 radian, 60 degree is equal to pi by 3 radian, 90 degree is equal to pi by 2 radian, and 180 degree is equal to pi radian, and 270 degree is equal to 3 pi by 2 radian, and 360 degree is equal to 2 pi. So remember this, memorize this table. This is very useful table. Notational convention means how can we note some value, like since angles are measured either in degrees or in radians, we adopt the convention that whenever we write angle theta degree, we mean the angle whose degree measure is theta, and whenever we write angle beta, we mean the angle whose radian measure is beta. That means theta represents the angle degree measure, and beta represents the radian measure. This is as per this textbook, but this is convention, and if you want to donate by different symbol, you have to mention that. Now when there is also a convention that when angle is expressed in radian, we generally omit radian word, that is pi is equal to 180 degree. That means pi radian is equal to 180 degree. We generally don't write radian word with the when we express the radian. That is understood. So radian measure is equal to pi by 180 degree into degree measure, and degree measure is equal to 180 degree by pi radian measure. So whatever you want to represent, substitute that value in the numerator. That will give the, if you want to measure in the degree, then write 180 degree in the numerator. If you want to measure in the radian, then you write the pi in the numerator. So let us take an example. Convert 40 degree 20 minute into radian measure. So we will use the pi radian is equal to 180 degree relationship, and with the help of that we can convert any degree into radian. So let us solve this. So 180 degree is equal to pi radian, therefore 40 degree 20 minute. So therefore 40 degree 20 minute can be written as the 40 degree plus 20 minutes, that means 1 by 3 degree. So for 20 minutes we will convert this by dividing by 60, that will be equal to 3 degree. So that means 40 plus 1 by 3 degree, and that is equal to pi by 180 degree into 121 by 3 radian. How? So 40 plus 1 by 3 degree into pi by 180. So 40 into 3 is equal to 120 plus 1, 121 by 3 into pi by 180. That will give this. So that is equal to 121 pi by 540 radian. Similarly, you can convert radians into degree. So solve this example number 2. That is very easy. If you have any doubt, please ask me in the comment box. So you have to convert the 6 radians into degree. So you know that pi radian is equal to 180 degree. That means 1 radian is equal to 180 degree by pi. So 6 radian is equal to divide into multiplied in by 6. So 180 by pi into 6, that is equal to this degree, and you can simplify this. So this gives this, and this can be converted into minute and seconds. So after simplification you will get this answer: 343 degree 38 minute 11 second. Now example 3, find the radius of the circle in which a central angle of 60 degree intercepts an arc of length 37.4 centimeter. So what we will do? We will use the relationship between arc length and radius of the circle. So theta is equal to L by R. So here it is asked to find the radius of the circle. Therefore R is equal to L by theta. So we will use this, and before using this we have to convert the degree into radian. It is must. So 60 degree is equal to pi by 3 radian. From the table you can also directly write 60 degree is equal to pi by 3 radian. Therefore R is equal to 37.4 into 3 by pi. We will divide by theta. So we will get this. Right. Firstly we will write 37.4 divided by pi by 3. So that will give this. Okay. So we will get this 35.7 centimeter. Now example 4. The minute hand of a watch is 1.5 centimeter long. How far does its tip move in 40 minutes? So you have to find the length of an arc. So what is given? Radius. Watch is the circular thing. So in a plane it makes a circle. So the minute hand, that means the radius of the circle, is given 1.5 centimeter, and it is asking the length of an arc swept by the minute hand in time 40 minutes. So what we will do? We will convert these 40 minutes into radian. So in 60 minutes the minute hand of a watch completes one revolution. Therefore in 40 minutes how much revolution it will make? 2 by 3 of the revolution. How? So you see 60 minutes makes one revolution. Therefore 1 minute 1 by 60. Therefore 40 minutes it will be 40 by 60. That will be equal to 2 by 3. So 2 by 3 of a revolution it will make in 40 minutes. Therefore theta is equal to 2 by 3 of 360 degree, because in one revolution it will make 360 degree. Therefore in 2 by 3 of a revolution, it is equal to 2 by 3 into 360 degree, and that is equal to 4 pi by 3 radian. You can convert it by multiplying pi by 180. Hence the required distance table is given by L is equal to r theta. So r is given 1.5 and theta 4 pi by 3, and that will give 2 pi centimeter, that is equal to 6.28 centimeter. So in this example you must remember, firstly you have to calculate the minutes into degree and minutes into the part, how much part of this complete revolution, and then it will convert into the radian, and after that we will apply the relation theta is equal to L by r. Similarly, you can do this example number 5. You do this, it is very interesting example. If you have any doubt, I will make you clear. Now let us discuss about the trigonometric functions. So as I told you that we have studied about the trigonometric ratios for acute angles as the ratio of sides of a right angle triangle, that is sin theta, cos theta, tan theta, we have studied, and I have already told you that I will give the link of that video, you can check it out. So what is sin theta of a right angle triangle? Sin theta is equal to perpendicular divided by the hypotenuse. Similarly, cos theta is equal to base divided by the hypotenuse, and tan theta is equal to perpendicular divided by the base. So we'll now extend the definition of trigonometric ratios to any angle in terms of radian measures and study them as trigonometric functions. So for that, let us consider a unit circle, that means circle of radius 1 unit, with the center at the origin of coordinate axis. So we are taking the Cartesian coordinates x and y, and we are putting the center of this triangle at the origin, and you can see from this figure 3.6 we are considering a point P on this circle which have coordinate a, b. That means if we are drawing a perpendicular from P to x-axis, that will give PM is equal to B and OM is equal to A, and angle that makes this is equal to x. So you can see that Cosec is equal to A and sin x is equal to B, because here hypotenuse is equal to 1, because we have taken the radius of the circle is 1 unit. So therefore we can see that 1 is equal to a square plus b square. 1 square is equal to a square plus b square, where a is equal to cos x and b is equal to sin x. After substituting this value, we will get cos square x plus sin square x is equal to 1, where x is the angle that is subtended by this arc AP, and ultimately this is right angle triangle OPM. So it can be generalized for any angle, that is x is the variable angle that is not fixed, it can be any angle. So therefore we can write in terms of theta, cos square theta plus sin square theta is equal to 1 always. This is an identity, you must remember it. Since one complete revolution subtends an angle of 2 pi radian at the center of the circle. Therefore, angle AOB is equal to pi by 2 and angle AOC is equal to pi and angle AOD is equal to 3 pi by 2. So all the angles which are integral multiple of pi by 2 are called quadrantal angles. So pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2 all are called the quadrantal angles. The coordinates of the points A, B, C and D are respectively can be given by A 1, 0, 0, 1, minus 1, 0 and 0, minus 1. Therefore, for a quadrantal angles, we have cos 0 is equal to 1, sin 0 is equal to 0, cos pi by 2 is equal to 0, sin pi by 2 is equal to 1 and cos pi is equal to minus 1, sin pi is equal to 0. So you must remember these values. This is very useful. Okay, cos 3 pi by 2 is equal to 0, sin 3 pi by 2 is equal to minus 1 and cos 2 pi is equal to cos 0 is equal to 1. Sin 2 pi is equal to sin 0 is equal to 0. So similarly, now we generalize these values for any angle, general angle. How can you find any angle in terms if you know this small values, sin, cos, tan values for small angles? You can find the sin, cos, tan for any bigger angle by utilizing the general concept. So now if we take one complete revolution from the point P, we again come back to same point P. After one complete revolution, we will back to the original point. Thus, we also observe that if x increases in the anti-clockwise direction or decreases in the clockwise direction by an integral multiple of 2 pi, the values of sine and cosine function do not change. So, after one complete revolution, if this is A, after one complete revolution, the value for sine, cosine doesn't change. So that means sine 2n pi plus any angle x is equal to sine x for n belonging to z integer and cos 2n pi plus x is equal to cos x for n belonging to z. Further, sin x is equal to 0 if x is equal to 0 plus minus pi plus minus 2 pi plus minus 3 pi. That means value of sine will be always 0 for the x is equal to 0, 2 pi, pi, 2 pi, 3 pi, 4 pi when x is an integral multiple of pi. Similarly, cos x is equal to 0 if x is equal to plus minus pi by 2, plus minus 3 pi by 2, plus minus 5 by 2. That is cos x vanishes. Cos x becomes 0 when x is an odd multiple of pi by 2. Okay. Therefore, sin x is equal to 0 implies x is equal to n pi and cos x is equal to 0 implies x is equal to 2n plus 1 pi by 2, odd multiple of pi by 2, where n is any integer. Okay, so remember this also. This is very important concept. Friends, actually we study NCERT books. That is very important textbook, and each and every line of these NCERT books are very important. We should not skip any concept. So that's why we are studying this textbook, so that we can be familiar with all those important concepts and tricks. Okay, so go one by one and try to understand the concepts. That may be helpful. Now we define other trigonometric functions in terms of sine and cosine functions. So you know cosec x is equal to 1 by sine x, sec x is equal to 1 by cos x, cot x is equal to 1 by tan x. How? This. And cot x is equal to cos x by sin x. So these are also important. That is the inverse function, inverse trigonometric functions. Now, since we know that sin square x plus cos square x is equal to 1, we can derive that 1 plus tan square x is equal to sec square x, 1 plus cot square x is equal to cosec square x. Okay, so let us solve this. So 1 plus tan square x is equal to 1 plus sin square x divided by cos square x is equal to cos square x plus sin square x divided by cos square x, and this numerator value is equal to 1. So 1 by cos square x, and 1 by cos square x is equal to nothing but sec square x. Similarly, you can solve this 1 plus cot square x is equal to cosec square x. So try to find this relation. If you have any doubt, please let me know in the comment box. Friends, you also must be familiar with this table. This is very important table. You should memorize, you should revise this table. This is very important. So from this table you can find the trigonometric value for any angle, that is sin, cos, tan. For any angle you can calculate. So the values for the values of cos x, sec x and cot x are the reciprocal of the values of sin x, cos x and tan x respectively. Sign of trigonometric functions. So we will now study about the sign conventions of the trigonometric functions, how we should be aware about the sign value in the different quadrangle. So let us know. Let P be a point on the unit circle with center at the origin and angle AOP is equal to x. So P is this, A is this, and O is this. So AOP is equal to x. Sorry. If angle AOQ is equal to minus x, then the coordinates of the point P, the coordinates of the point Q will be A minus B, because this side is positive. So if you go in the clockwise side, this value will be negative, minus x, and therefore this value will be equal to minus b. So because of this, the coordinate of Q will be written as a comma minus b. Therefore cos of minus x is equal to cos x, because cos x is always given in terms of the base when the hypotenuse is equal to 1. So that is here A is not changing its sign. Therefore cos of minus x is equal to cos x, but sin minus x is equal to minus sin x, because sin is given in terms of b and here b changes its sign. Therefore it becomes negative. Therefore sin minus x is equal to minus sin x. So we just know that the sin of plus theta is equal to sin theta and sin of minus theta is equal to minus sin theta. But how it comes, you can understand this concept in this text, NCERT textbooks. That is very important. Okay. Now since for every point P, AB on the unit circle lie 1 minus 1 is less than equal to A is less than equal to 1, that means the value for any point on this unit circle lies between minus 1 to 1 and minus 1 to 1 for B. Hence value for cos x and sin x will always be lying between minus 1 to 1. for all angle x. We also know that for quadrangle, a particular quadrangle have particular sign convention. So we know that the value for theta lying between 0 to pi by 2, a and b both are positive, means x-axis and y-axis both are positive for the first quadrangle. And in the second quadrangle that lies between pi by 2 and pi, a is negative, that is x-axis becomes negative, but y-axis, that is b, is positive. In the third quadrant that lies between pi and 3 pi by 2, a and b both are negative. And in fourth quadrant, 3 pi by 2 to 2 pi, a is positive, b is negative. Therefore, sin x is positive for 0 to pi, because in that case b is positive, that is y quadrant is positive, and negative for pi to 2 pi, because in that case b is negative. Similarly, cos x is positive for 0 to pi first quadrant and negative for pi by 2 to 3 pi by 2, that is third quadrant, and also positive for fourth quadrant. So similarly we can find the sign conventions for the other trigonometric functions. So check this table. From this you can see the sign for different trigonometric function in different quadrant. So you can see that sin x is positive for first and second quadrant and negative for third and fourth quadrant. Cos x is positive for first quadrant and the fourth quadrant and negative for second and third. Similarly, tan x is positive for first quadrant and third quadrant, and cos x is positive for first quadrant and second quadrant. So similarly you can check for the other trigonometric functions. Now, domain and range of trigonometric functions. What is the domain and range of a trigonometric function? From the definition of sine and cosine, we observe that they are defined for all real numbers. Further, we observe that for each real number, x minus sin x lies between -1 and 1, and cos x lies between -1 and 1 for all real numbers. So thus domain of y is equal to sin x and y is equal to cos x is set of all real numbers, and range is the interval -1 and 1, that is y lying between -1 and 1. So friends, now we will discuss about the domain and range for the reciprocal functions, trigonometric functions. For example, let us talk about the cosec x. So you know that the domain of sin x is the set of real numbers. So in the case of cosec x, the domain of y is equal to cosec x is the set of real number x colon x belonging to the real number, but x should not be equal to n pi, because for x is equal to n pi the sign value becomes 0, and in that case y will be equal to 1 by 0, that means undefined or infinite. So we will not take the value for x is equal to n pi in case of the cosec x. So condition is that for y is equal to cosec x, x should not be equal to n pi. And range is the set of real number, and here the value for y will be greater than equal to 1 and or y is less than equal to minus 1. That is just opposite to the value for sin x. Similarly, the domain of y is equal to sec x is the set of real number where x would not be equal to 2n plus 1 pi by 2, because you know that sec x is equal to 1 by cos x, and cos x for x is equal to the odd multiple of pi by 2 becomes 0. So we will not take the value of odd multiple of pi by 2 in the case of sec x. And range is the set of real number where y should be equal to and less than minus 1, or y should be greater than equal to 1. The domain of tan x, y is equal to tan x, is the set of real number, and again x should not be equal to 2n plus 1 pi by 2. And range for this y is equal to tan x is the set of all real numbers. Similarly, you can find the range and domain of other trigonometric functions. Now see this table, that is very important. For different quadrant, we are given the trigonometric functions variations. So for first quadrant, the trigonometric function sin increases from 0 to 1, and as we move from quadrant 1 to 2, it decreases from 1 to 0 again, and for the third quadrant it again decreases from 0 to minus 1, and for the fourth quadrant it comes to its initial value minus 1 to 0. That means it completes one circle. First it increases from 0 to 1, then it decreases from 1 to 0, then it again decreases from 0 to minus 1, and then it comes back to its initial position 0 to 1, minus 1 to 0. Similarly, we can take the cos x variation for the different quadrant. So cos x decreases first from 1 to 0, then decreases from 0 to minus 1, and increases from minus 1 to 0, and increases from 0 to 1. Okay, so it is pi by 2 out of phase with the sign. Okay, because you know the value of cos x and sin x matches like this. Okay, you can check this. It is again always pi by 2 phase difference. So now tan x variation in the first quadrant, that value for tan increases from 0 to infinite, and for the second quadrant it increases from minus infinity to 0, and for third quadrant increases from 0 to infinity, and for the fourth quadrant it increases from minus infinity to 0. So you can see that it is always increasing from 0 to infinity, minus infinity to 0, from 0 to infinity, and from minus infinity to 0. And cot always decreases from infinity to 0, 0 to minus infinity, from infinity to 0 again, and from 0 to infinity. So you can see and check all these variations from this table. Now in the above table, the statement tan x increases from 0 to infinity for the first quadrant lying between 0 and pi by 2 simply means that tan x increases as x increases for the angle lying between 0 to pi by 2, and assumes arbitrarily large positive values as x, that is angle, approaches to pi by 2. Similarly, to say that cosec x decreases from minus 1 to minus infinity in the fourth quadrant means that cosec x decreases for x belonging to 3 pi by 2, 2 pi, and assumes arbitrarily large negative values as x approaches to 2 pi. Symbol infinite and minus infinite simply specifies certain types of behavior of functions and variable. Now you can see from this figure 3.8 the variation of sin x. So you can see that when the angle varies from 0 to pi by 2, its value becomes maximum, that is 1, and again as we move from pi by 2 to pi, it start decreasing. From pi to 3 pi by 2, it becomes again negative minus 1, and from 3 pi by 2 to 2 pi, it comes to initial position. So this total value completes a one revolution or one cycle. Okay. Similarly, you can check it for the negative angle also. Now the variation of cos x, you can see that when the value for 0, x is equal to 0, the value for cos x is equal to maximum, that is equal to 1, while the value for sin x for theta is equal to 0 or angle is equal to 0, it is 0. So when sin x is equal to 0, cos x is equal to 1. So they are out of phase by pi by 2. Correct? So as we move from 0 to pi by 2, the value for cos x becomes 1 to 0, and 3 pi by 2 to pi, it becomes minus 1, and pi by 2 to pi, it becomes minus 1, and pi to 3 pi by 2, it becomes 0 again. So it completes one cycle. Okay, now so we start from 1 to 0, 0 to minus 1, minus 1 to 0, 0 to 1. Here it completes one cycle. Now we will take the variation of tan x. Here you can see from the diagram, we are plotting the x on the x coord and y axis. Here x is equal to 0. So when x is equal to 0, tan is equal to 0. As the x increases from 0 to pi by 2, the value for tan x approaches to enormous value, that is infinite. So you can see this is moving towards infinite. And similarly, when we move in the negative direction, when the angle moves in the minus pi by 2, it also decreases towards minus infinity. So you can check it that the variation for tan x is given by this type of curve, and when we move from pi by 2 to pi, then the value increases from minus infinite to 0, and when we move from pi to 3 pi by 2, the value increases from 0 to infinite. So this type of variation is followed by the tan x. That is very important, that is very crucial, and you should note it down. Similarly, we can check for the variation of cot x, and if you have any doubt, you please let me know in the comment box. I will clear it. And this is the variation for sec x and cosec x. When the value for x is equal to 0, the sec x value becomes 1, and when it is increasing from 0 to pi by 2, the sec x value goes towards the infinite on both sides. Okay, now we will solve the example number 6. If cos x is equal to minus 3 by 5, x lies in the third quadrant, find the values of other 5 trigonometric functions. That means cos x is given, we have to find the values for sin x, tan x, sec x, cosec x, cot x, okay, with the help of this conditions. So we will find the x values. So cos x is equal to minus 3 by 5. That means sec x is equal to minus 5 by 3. So as we know that sin square x plus cos square x is equal to 1. That is sin square x is equal to 1 minus cos square x. So we can find the value for sin x. Since x lies in third quadrant, and in third quadrant sin value is negative, so we will take the negative values. Similarly, cosec x is the reciprocal of sin x, that is minus 5 by 4. Now tan x is equal to sin x by cos x, we can calculate that. Cot x is also calculated by this relation. Now move to the example number 7. If cot x is equal to minus 5 by 12 and x lies in the second quadrant, find the values of other 5 trigonometric functions. So with the help of cot x, we will calculate the other values. So we can write tan x is equal to minus 12 by 5. Therefore, by the relation sec square x is equal to 1 plus tan square x, we can calculate the sec square x by substituting for the values of tan x. That is sec square x is equal to 1 plus 144 by 25. Therefore, sec x is equal to plus minus 13 by 5. So now we have to choose what the sign we have to take. Since it is given that the angle x lies in second quadrant, and since sec x in the second quadrant is negative, as cos x is negative in the second quadrant also, therefore we will take the negative value. Therefore sec x is equal to minus 13 by 5. Similarly, we can get cos x is equal to minus 5 by 13, that is reverse of the sec x. Further, sin x is equal to tan x into cos x, so we can calculate sin x is equal to 12 by 13, and therefore cosec x is equal to reciprocal of the sin x, that is 1 by sin x. Therefore cosec is equal to 13 by 12. So friends, we can calculate in this way. Now take up the example number 8. So in this example, it is given that find the value of sine 31 pi by 3. So we have to calculate the sine 31 pi by 3. So firstly we will simplify this angle in terms of 2 pi. So that is sine 31 pi by 3 can be written as sine 10 pi plus pi by 3, and where 10 pi can also be written as in terms of 5 into 2 pi. So that means the value for sine will be plus sine. So sine 10 pi plus pi by 3 is equal to sine pi by 3, and we know that sine pi by 3, that means sine 60 is equal to square root 3 by 2. So in this way we can calculate the value. So friends, now take up the example number 9. So in this example you have to calculate the value for cos of minus 1710 degree. So firstly, there are two ways. One is given in this solution. Now you can also do this by second method. So you know that cos of minus theta is equal to cos theta. So first of all, cos of minus 17 degree 1710 degree can be written as cos of 1710 degree. So that is equal to cos of 4 into 360 plus 270, and that is equal to cos of 270, and this is nothing but cos 3 pi by 2, that is equal to 0. So answer will be same in both way. Similarly friends, you can perform the exercise number 3.2 and you can calculate the values for cos x, sin x, cot x, sec x and tan x. So you can calculate all those values because we have discussed all the related examples. Now take up the topic 3.4, trigonometric functions of sum and difference of two angles. So that means you have to find the trigonometric function for summation or difference of two angles or more than two angles. So let us derive expressions for trigonometric functions of the sum and difference of the two angles or numbers. So as you know that sin of minus x is equal to minus sin x and cos of minus x is equal to cos x. Now let us solve cos x plus y is equal to cos x cos y minus sin x sin y. So for this to derive, let us consider a unit circle with the center at the origin. So this is the xy coordinate system and we are considering the unit circle having the center at origin O. So this is origin. Now let x be the angle P4OP1 and y be the angle P1OP2. So this is the angle x and this is the angle y. Then x plus y is the angle P4OP2. That means this. Also let minus y be the angle P4OP3. This angle. Therefore P1, P2, P3 and P4 will have the coordinates P1 cos x sin x, P2 cos x plus y sin x plus y, P3 cos minus y minus sin sin minus y and P4 1, 0. So with the help of this diagram, we can consider the triangle P1P3, P1OP3 and P2OP4 and they are congruent. Therefore P1P3 and P2P4 are equal, and by using the distance relation we can write P1P3 square is equal to cos x minus cos of minus y whole square plus sin x minus sin of minus y whole square, and after simplification this will be equal to 2 minus 2 cos of x into cos of minus y minus 2 minus 2 into cos x into cos y minus sin x into sin y, and similarly we can calculate P2 P4 square and we'll get 2 minus 2 cos x plus y. Since P1 P3 is equal to P2 P4 and we have P1 3 square is equal to P2 P4 square, therefore this is equal to this, and hence cos x plus y is equal to cos x cos y minus sin x sin y. Similarly, we can calculate cos x minus y by replacing y by minus y in the above identity, and we can get cos x minus y is equal to cos x into cos y plus sin x into sin y. By application of this, we can calculate cos pi by 2 minus x is equal to sin x, and this becomes also an identity. So remember this relation, cos of pi by 2 minus x is equal to sin x, and sin pi by 2 minus x is equal to cos x. So just substitute this x by pi by 2 and y by x in the identity 4, we will get cos pi by 2 minus x is equal to cos pi by 2 into cos x plus sin pi by 2 into sin x is equal to sin x, as cos pi by 2 is equal to 0 and sin pi by 2 is equal to 1. So we will get sin. Similarly, we can get the value for sin pi by 2 minus x is equal to cos x. Now the identity sin x plus y is equal to sin x cos y plus cos x sin y. So note the order of this: sin x cos y plus cos x sin y, and we can prove this by sin x plus y is equal to cos pi by 2 minus x plus y, and that will give cos pi by 2 minus x minus y, and after writing the relationship cos of x minus y, we can write this and we will get the relation sin x plus y is equal to sin x cos y plus cos x sin y. Similarly, sin x minus y is equal to sin x cos y minus cos x sin y, and this can be obtained by replacing y by minus y in the identity 7 sin x plus y. By taking suitable values of x and y in the identities 3, 4, 7 and 8, we get the following results. So first of all is that do you remember this relation? This is very important. Okay. So friends, you can remember all these identities. These are very important and this will be helpful in solving many trigonometric problems. So sin of pi by 2 minus x or sin of pi by 2 plus x is equal to cos x, and cos pi by 2 minus x is equal to sin x, and cos pi by 2 plus x is equal to minus sin x. Cos of pi minus x is equal to minus cos x, and sin of pi minus x is equal to sin x. So you note the relations and their orders very carefully, and you can remember this relation. You can check this: cos pi by pi minus x is equal to minus cos x, but cos pi plus x is also minus cos x. So cos of pi plus x or cos of pi minus x both are equal to minus cos x. Sin pi minus x is equal to sin x, but sin pi plus x is equal to minus sin x, because the sin value in the third quadrant pi plus x is negative, so this value will take minus. And cos of pi minus x and cos of pi plus x both gives the negative, because the cos values in second quadrant and third quadrant are negative, that's why the negative value comes. And cos of 2 pi minus x is equal to cos x, and sin 2 pi minus x is equal to minus sin x, because you know that sin value in the fourth quadrant is negative, so that's why. Okay, so you can remember by this trick, by applying these quadrant sign conventions, you can remember the relationship. Now point number 10: if none of the angles x, y and x plus y is an odd multiple of pi by 2, then the condition is that x, y and x plus y is not odd multiple of pi by 2. Then we can write tan x plus y is equal to tan x plus tan y, divided by 1 plus tan x into tan y. So this is the relationship for the tangent of the summation of two angles. Now, since none of the x, y and x plus y is an odd multiple of pi by 2, it follows that cos x, cos y and cos x plus y are non-zero. Otherwise, it will be 0 because cos of odd multiple of pi by 2 is equal to 0. That like pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, all are 0 for the cos. So these are non-zero. So we can write tan x plus y is equal to sin x plus cos x plus y, and by applying sin x plus y is equal to sin x cos y plus cos x sin y, and cos x plus y is equal to cos x cos y minus sin x sin y. By dividing numerator and denominator by the cos x cos y, we get this, and after simplification we get tan x plus tan y divided by 1 minus tan x tan y. Similarly, we can get tan x minus tan y was just by replacing y by minus y, we will get the relation. Okay, so note it. So we have to divide the numerator and denominator by the cos x cos y, means by this, because we want this to be 1. So we divide numerator and denominator by this value and we will get this relation. If now point number 12, if none of the angles x, y and x plus y is a multiple of pi, then we can write cot x plus y is equal to cot x cot y minus 1 divided by cot y plus cot x. So condition is that the angle should not be the multiple of the pi, because in this case cot x can be written as cos x by sin x, and sin x should not be 0, or sin x plus y should not be 0. That means angle should not be the multiple of pi. That's why we should have this condition. So we can write cot x plus y is equal to cos x plus y by sin x plus y, and by using the relationship for the cos of summation of the two angles cos x cos y minus sin x sin y, and sin x plus y is equal to sin x cos y plus cos y cos x sin y. So now we have to divide the numerator and denominator by sin x sin y. So we'll get this, and we can also get this cot x minus y by replacing y by minus y in this relation. We will get the value for cot x minus y is equal to cot x cot y plus 1 cot y minus cot x. So you should note that in this difference between these two relations, so here minus sign and here plus sign, here plus sign, here minus, so sign changes for the cot x minus y. Now the condition cos 2x is equal to cos square x minus sin square x, that can be written as 2 cos square minus 1 is equal to 1 minus 2 sin square x. This is very important relationship. It is very important in the sense that it can be useful for simplifying the many trigonometric relationships, trigonometric problems. So remember this. Remember this relation: cos 2x is equal to cos square x minus sin square x, that is equal to 2 cos square minus 1, that is equal to 1 minus 2 sin square x, and can also be written in terms of the tan x, that is 1 minus tan square x divided by 1 plus tan square x. We can prove this also. So let us solve this. So we know that cos x plus y is equal to cos x cos y minus sin x sin y, and replace y by x so that we can get the 2x. So cos 2x, x plus x is equal to cos 2x. Therefore we get cos square x minus sin square x. So first relation is proved. Now since we know that cos square x is equal to 1 minus sin square x, So after substituting that, we can get this 1 minus 2 sin square x, and we know that sin square x is equal to 1 minus cos square x, so we'll get this and we'll get the final. Similarly, we know that cos 2x is equal to cos square x minus sin square x, and dividing this by cos square x plus sin square x, that is equal to 1. So there is no difference, so we can write this. Now divide numerator and denominator by cos square x, so we will get this. Condition is that x should not be equal to n pi plus pi by 2, where n is an integer. Now sin 2x is equal to 2 sin x cos x, that is equal to 2 tan x divided by 1 plus tan square x. Condition is that x should not be odd multiple of pi by 2. So this is also very important relation. You should remember this. Sin 2x is equal to 2 sin x cos x is equal to 2 tan x divided by 1 plus tan square x. So you can we can derive this by this relation, sin x plus y. Substitute y is equal to x and we will get sin 2x, and we get here 2 sin x cos x divided by cos square x sin square, because we are dividing this relation by 1. So we will get this, and divide this by cos x, we will get the 2 tan x divided by 1 plus tan square x. Similarly, we can get tan 2x is equal to 2 tan x divided by 1 minus tan square x. We know that relation tan x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. So replace the y by x, we will get this tan 2x is equal to 2 tan x divided by 1 minus 2 tan square x. Similarly, you can prove the relation sin 3x is equal to 3 sin x minus 4 sin cube x by using the relation for the sine of summation of two angles. So 3x can be rewritten by x plus 2x. So we will use this relation, and after simplification we will get the result. So similarly, we can prove cos 3x is equal to 4 cos cube x minus 3 cos x. So these are the identities which we remember. So sin 3x is equal to 3 sin x minus 4 sin cube x, cos 3x is equal to 4 cos cube x minus 3 cos x. Just you can remember this by using the trick that after sin 3x, 3 sin x is starting, cos 3x, 4 cos cube x is starting. So they are switching their values. So these are the identity, you can easily prove this. Okay. Also this point 20 cos x plus cos y is equal to 2 cos x plus y by 2 cos x minus y by 2. These are the very useful identities. You can remember this in terms of summation half of the angle. Means trigonometric function in terms of half of the summation of angle or any angle. So let us solve first identity. Cos x plus y is equal to 2 cos x plus y by 2 cos x minus y by 2. So firstly we use the cos x plus y is equal to cos x cos y minus sin x sin y, and also we know that cos x minus y is equal to cos x cos y plus sin x sin y, and subtracting and adding these two identity will get these two relations. Further, using the relation sin x plus y and sin x minus y, and again adding these and subtracting these, will get these identities. So now let x plus y is equal to theta and x minus y is equal to phi. Therefore these x can be written in terms of theta and phi. By this, x is equal to theta plus phi by 2 and y is equal to theta minus phi by 2, and substituting these values in this, we can get cos theta plus cos phi is equal to 2 cos theta plus phi by 2 cos theta minus phi by 2, and cos theta minus cos phi is equal to minus 2 sin theta plus phi by 2 sin theta minus phi by 2. So here if you should note that if we are changing the sign, minus sign is coming out, and sin theta plus sin phi is equal to 2 sin theta plus phi by 2 cos theta minus phi by 2. So these are the relations we can remember, and if you want to write in terms of x and y, you can replace theta by x and phi by y, you will get the same relation. So there is no problem, you can remember this or this. Okay. So these are the also relations which we proved by adding and subtracting the identities. So now let us take the example number 10. So prove that 3 sin pi by 6 sec pi by 3 minus 4 sin 5 pi by 6 cot pi by 4 is equal to 1. So you have to solve this. How can we solve this? Just you take the LHS left hand side of the problem and start putting the values for corresponding sine, sec value. So you know sin pi by 6 is equal to 1 by 2 into sec pi by 3 is equal to 2 because cos pi by 3 is equal to 1 by 2, and minus 4 sin 5 pi by 6 can be written in terms of pi minus pi by 6. So sin pi minus x is equal to sin x, that means you will get sin pi by 6. So sin pi by 6 again is equal to 1 by 2, so the answer is 1, that is equal to RHS, that is hence proved. Find the value of sin 15. So you know the value for sin 45, you know the value for sin 30, so you will use the sin 45 degree minus 30 degree. So this, and therefore sin x minus y can be written as sin x into cos y minus cos x into sin y. So after substituting these values you can get the answer. Now find the value for tan 13 pi by 12. So that can be written as 13 pi by 12 is equal to pi plus pi by 12, and tan pi plus pi by 12 is equal to tan pi by 12, which is further can be written as pi by 4 minus pi by 6. So tan x minus y is equal to tan x minus tan y divided by 1 plus tan x into tan y. So after substituting the value for x and y and hence solving for the tan x and tan y, you will get the answer. And now you can solve this by multiplying the numerator and denominator by the square root 3 minus 1. So you will get the answer. Similarly, prove that example 13 sin x plus y divided by sin x minus y is equal to tan x plus tan y divided by tan x minus tan y. So what you will do, let us take the LHS part and we will expand it, sin x plus y and sin x minus y, will get this, and divide this by cos x cos y, then you will get tan x plus tan y divided by tan x minus tan y. Okay, so see how can you decide by which quantity you have to divide to get the obvious result. So see, in this question you are asked tan x plus tan y, so that means you have to divide this sin x by cos x and you have to eliminate this cos y. So if you divide this value by cos x cos y, then you will get the result. So that is the trick, remember this. Now example 14, so that tan 3x tan 2x tan x is equal to tan 3x minus tan 2x minus tan x. So let us solve this. So tan 3x can be written as tan 2x plus x, and we apply the formula tan x plus y. So tan x plus tan y divided by 1 minus tan 2x tan x. So this, and therefore after solving this tan x we multiply crosswise. So tan 3x minus tan 3x tan 2x tan x is equal to tan 2x plus tan x. After simplification we get the result. So friends, try to solve this. These are very obvious solutions, and if you are finding any difficulties, please let me know in the comment box. I will provide you the guidance and solutions. Okay, now prove that cos pi by 4 plus x plus cos pi by 4 minus x is equal to square root 2 cos x. So what will you do? You will take the LHS and you will expand this 2 cos pi by 4 plus. So what you will do? You will use the formula cos x plus cos y is equal to 2 cos x plus y by 2 into cos x minus y by 2. So that relation is useful here. This relation, see, you have to cos x plus cos y, this. Okay, or you can see this same thing. Okay, so remember these all identities. It will be very useful for solving the problems. Now prove that cos 7x plus cos 5x divided by sin 7x minus sin 5x is equal to cot x. So you will use the identity cos x plus cos y, that will be equal to 2 cos x plus y by 2 into cos x minus y by 2. Similarly sin x minus sin y, will use that 2 cos x plus y by 2 into sin x minus y by 2. After simplification you will get cos x by sin x is equal to cot x. Okay, so practice the results by remembering all those identities, and you will be able to solve those problems. Okay, similarly you can do this. Now these are the exercise. Practice all these questions. You can easily solve it after application of the results what we have discussed previously in this video lecture. Now the trigonometric equations. Equations involving trigonometric functions of a variable are called trigonometric equations. We shall find the solutions of such equations. The solutions of trigonometric equation for which the x is greater than equal to 0 and x is less than 2 pi are called principal solutions. So if you solve the trigonometric equation for an angle that lies between 0 and 2 pi, that solution is called the principal solution. The expression involving integer n which gives all solutions of a trigonometric equation is called the general solution. So if you are using n in any solution, then the solution will be generalized solution, general solution. Now solve the example 18. Find the principal solutions of the equation sin x is equal to square root 3 by 2. So you know that for x is equal to pi by 3 this values comes, but we need the principal solution. So you know that sin pi by 3 already I have told, and sin 2 pi by 3 is equal to also again square root 3 by 2. That means principal solutions are x is equal to pi by 3 and 2 pi by 3. Because sin is positive in two quadrants, quadrant number 1 and quadrant number 2. So you get the two values. Find the principal solutions of the equation tan x is equal to minus 1 by square root 3. So you know that tan pi by 6 is equal to 1 by square root 3. Therefore, tan pi minus pi by 6 is equal to minus tan pi by 6, that is equal to minus 1 by square root 3. Again, tan 2 pi minus pi by 6 is also negative values, minus tan pi by 6, that is equal to minus 1 by square root 3. Therefore, we get two values, pi minus pi by 6 and 2 pi minus pi by 6, that is 5 pi by 6 and 11 pi by 6. Okay, so the principal solutions are 5 pi by 6 and 11 pi by 6. Now let us find the general solutions of trigonometric equation. We already know that sin x is equal to 0 gives x is equal to n pi, and cos x is equal to 0 gives x is equal to odd multiplication of the pi by 2, that is 2n plus 1 pi by 2. Now we will use this result. For any real number x and y, sin x is equal to sin y implies that x is equal to n pi plus minus 1 to the power n y. That means x and y will be having the values that lying in the range of x is equal to n pi plus minus 1 to the power n y. That is, x and y is related by this equation, x is equal to n pi plus minus 1 to the power n y. Now let us prove this. So if sin x is equal to sin y, then sin x minus sin y is equal to 0. Now by relation, sin x minus sin y is equal to 2 cos x plus y by 2 into sin x minus y by 2, that is equal to 0. And therefore cos x plus y by 2 is equal to 0 and sin x minus y by 2 is equal to 0. This implies that x plus y by 2 is equal to odd multiplication of pi by 2, and similarly x minus y by 2 is equal to n pi. So this leads to x is equal to 2n plus 1 pi minus y, and x is equal to 2n pi plus y. So ultimately we get x is equal to 2n plus 1 pi plus minus 1 to the power 2n plus 1 y, or x is equal to 2n pi plus minus 1 to the power 2n y. So you can check it that for n is equal to 1, 2, 3, this relation is valid. So combining these two relations, this and this, we can write n pi plus minus 1 to the power n y. Okay, so these are the generalized solutions. So friends, similarly we can show that for cos x is equal to cos y, x is related to y by this, x is equal to 2n pi plus minus y. So let us solve this. So cos x is equal to cos y is given, that means cos x minus cos y is equal to 0. By using the relation cos x minus cos y is equal to minus 2 sin x plus y by 2 sin x minus y by 2 is equal to 0. Therefore, separately sin x plus y by 2 is equal to 0 and sin x minus y by 2 is equal to 0. That means either this is 0 or this is 0. So that means x plus y by 2 is equal to n pi, or x minus y by 2 is equal to n pi, where n is an integer. So from this relation, x is equal to 2n pi minus y or x is equal to 2n pi plus y. That means either x is equal to 2n pi plus y or x is equal to 2n pi minus y. So combining these two relations, we get x is equal to 2n pi plus minus y for any integer n. Now theorem number 3, prove that if x and y are not odd multiple of pi by 2, then tan x is equal to tan y implies that x is equal to n pi plus y. That means now we will prove for the tan trigonometric function tan x is equal to tan y, the relation x is equal to n pi plus y also holds, provided the x and y are not an odd multiple of pi by 2. So tan x is equal to tan y, that means tan x minus tan y is equal to 0, which implies that sin. So what we will do, we will write tan x is equal to sin x divided by cos x minus sin y divided by cos y is equal to 0. After simplification, we will get this, which gives sin x minus y is equal to 0. Why? Because cos x into cos y can't be 0. That means this is 0, sin x minus y is equal to 0, which implies that x minus y is equal to n pi, that is x is equal to n pi plus y. So we proved that tan x is equal to tan y only when x is equal to n pi plus y. Now example 20, find the solution of sin x is equal to minus square root 3 by 2. So we know that sin x is equal to minus square root 3 by 2 is equal to minus sin pi by 3. And this can be written as sin pi plus pi by 3, that is 4 pi by 3, sin 4 pi by 3. Therefore sin x is equal to sin 4 pi by 3. This implies that x is equal to n pi plus minus 1 to the power n 4 pi by 3. Note, 4 pi by 3 is one such value of x for which sin x is equal to minus square root 3 by 2, and one may take any other value of x for which sin x is equal to minus square root 3 by 2. The solution obtained will be the same, although these may apparently look different. So you can get 4 pi by 3 is the solution for which sin x is equal to minus square root 3 by 2, and you can also get, for suppose you are writing for n equal to 1, so x is equal to pi minus 4 pi by 3, that is equal to minus pi by 3. So minus pi by 3 is also a solution. Okay. Similarly, for n is equal to 2, we can get 2 pi plus 4 pi by 3, that is 6 plus 4, 10 pi by 3 is also an solution for sin x is equal to minus square root 3 by 2. That means you can get number of solutions for a particular equations. This is why it is called the general solution. Now example 21, solve cos x is equal to 1 by 2. We know that x is equal to pi by 3. So but we want to get the general solution, so that's why we will keep 2n pi plus minus pi by 3 by the relation x is equal to 2n pi plus minus y. So after substituting for y is equal to pi by 3, we get the general solution. Similarly, we can solve the example number 22. Now example number 23. Solve sin 2x minus sin 4x plus sin 6x is equal to 0. So we will write the left hand side sin 6x x plus sin 2x minus sin 4x. So this will give sin 6x plus sin 2x, sin x plus sin y is equal to 2 sin x plus y by 2 cos x minus y by 2. Then we will get this, then this. Now 2 sin a cos a, that is sin 2a, that is 2 sin so we'll take out the common here, sin 4x, so it will be remaining this 2 cos 2x minus 1, and sin x, either sin 4x is equal to 0 or cos 2x minus 1, 2 cos 2x or 2 cos 2x minus 1 is equal to 0. This will give cos 2x is equal to 1 by 2. That means cos 2x is equal to cos pi by 3. So either 4x is equal to n pi or 2x is equal to 2n pi plus minus pi by 3. So x is equal to n pi by 4 or x is equal to n pi plus minus pi by 6. So this is the solution. Similarly, we can solve for this 24 number example. So you will solve it. So practice all these solutions and you will be more familiar with these problems. When you practice a lot, you can solve this one by one. These are already solved. So miscellaneous exercise number exercise based on this chapter. So these are the problems, you have to practice it. So now I will summarize this lecture that we have discussed in this video lecture. If in a circle of radius r, the arc of length L subtends an angle of theta radians at the center of the circle, then relation arc is equal to radius into angle, that is L is equal to r theta. Radian measures is given by pi by 180 into degree measure. So I always reminded you that if you want to get the radian, write pi in the numerator. Similarly, when you want to measure in degree, then write 180 degree in numerator, so you will get the radian. And this is very famous relation, cos square x plus sin square x is equal to 1, 1 plus tan square x is equal to sec square x, 1 plus cot square x is equal to cosec square x, and the general solution cos 2n pi plus x is equal to cos x, sin 2n pi plus x is equal to sin x, and sin minus x is equal to minus sin x, and cos minus x is equal to cos x. Cos x plus y is equal to cos x cos y minus sin x sin y. Cos x minus y is equal to plus sin. This cos x into cos y plus sin x into sin y. Cos pi by 2 minus x is equal to sin x, and sin pi by 2 minus x is equal to cos x. So these are the very famous relations. Sin x plus y is equal to sin x cos y plus cos x sin y. Sin x minus y is equal to sin x cos y minus cos x sin y, and cos pi by 2 plus x is equal to minus sin x, and sin pi by 2 plus x is equal to cos x. As I already told you that what are the reasons for these signs. Cos pi minus x is equal to minus cos x, sin pi minus x is equal to sin x, cos pi plus x is equal to minus cos x, and sin pi plus x is equal to minus sin x. Cos 2 pi minus x is equal to cos x, sin 2 pi minus x is equal to minus sin x, because sin x is positive for quadrant 1 and 2, and cos x is positive for quadrant 2 and 4. So if none of the angles x and y and x plus minus y is an odd multiple of pi by 2, then these relation tan x plus y and tan x minus y are valid. Similarly, we can prove these relations. So these are the relations which we proved in this sin 2x is equal to 2 sin x cos x, that is equal to 2 tan x by 1 plus tan square x, and tan 2x is equal to 2 tan x divided by 1 minus tan square x. Sin 3x is equal to 3 sin x minus 4 sin cube x. cos 3x is equal to 4 cos cube x minus 3 cos x, and tan 3x is equal to 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So remember these all relations. Cos x plus cos y is equal to 2 cos x plus y by 2, cos x minus y by 2, cos x minus y is equal to minus 2 sin x plus y by 2 into sin x minus y by 2. This can also be written as 2 sin x plus y by 2 into sin y minus x by 2. So these are also true. Sin x plus sin y is equal to 2 sin x plus y by 2 into cos x minus y by 2, and sin x. So try to remember by trick. When cos plus x plus y, cos x plus cos y is given, the relation is coming in the form of cos and cos only, cos x plus y by 2 and cos x minus y by 2. When negative sign is this here, so relation is coming in the form of sin x plus y by 2 and sin x minus y by 2. But when the relation is sin x plus sin y, then the relation is sin and cos both, sin x plus y by 2 cos x minus y by 2 into 2, and negative sign comes when then 2 cos x plus y by 2 into sin x minus y by 2. So try to find the difference. When the plus sign is here, the cos value is coming with the difference of the angle, and when sin x minus sin y is a negative sign here, then the sin value is coming with the difference angle. I hope that you enjoyed this video lecture and learned about the trigonometry functions, trigonometric relations, their general solutions, their particular solutions, all those things in this video lecture. If you like this video, please give the thumbs up, and I would like to remind you that please remember these all relations by practicing on paper with the help of pencil, because it demands a lot of practice. Without practice, it is not possible to remember all those relations. So please try to practice all these relations. So friends, these are all which I wanted to discuss in this video lecture. If you have not subscribed the Sciacademy channel, please subscribe it so that you can get the upcoming video notification on time, and you could not miss this video lecture. And please share these video lectures with your friends and colleagues so that they can also learn about these video lectures. These are very useful and important video lectures because I am here discussing the NCERT textbooks, because many of the questions are asked directly from the NCERT textbooks. So these textbooks are very important. So try to learn these all concepts. Thank you, friends.